I was sure that we have a standard week today, and something strange happened because you have exams in a few days. So today we will not cover new topics. So we will just relax. I will answer your questions. If you have no questions, then I will solve something that seems difficult to me. But you are free to ask your questions. No new topics covered today. Just relax. And I think because um, of this is understanding about timetable. So we will have not 1 hour of consultations before exam, but 2. So you are free to ask your questions. If you have any difficulties, then just be brave and ask. No new topics covered today.
Can we solve problem number 7 from last home assignment?
I think the deadline is passed, and
Yes, it's already.
I think we can. So let me open it. Just a moment. I will find it. Just 1 moment. I will open it because I have some difficulties with network at High School of Economics. I don't understand. I especially arrived here. Just a moment. 1 minute, and I will. I think I will find it. Okay. 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 Let's find it as um, yeah, here it is. Okay. So we have number 7. So it is something dyt is yt dt plus t cube plus 4yt dwt and y0 is 1. Okay. So first we have a hint. So let's just go by hints. And so we are supposed to solve a simplified equation. So let's solve. So let's forget about this t cube. Okay. So for the moment, let's just forget about t cube. So we are proposed to solve a simpler version of this equation. Solve something simple. So we are proposed to solve an equation where t cube is missing. 4at dyt. So basically, we see that we have already solved this equation. I can solve it once again, but basically, if you remember Black-Scholes model, like it was like mu st dt plus sigma st dyt, and we have solved it. So if you like, I can once again tell the solution process, or shall I use the result we have obtained? So as you wish, I can solve it once again, or I can just write the result I remember, that is mu minus sigma squared over 2t plus sigma wt. So shall I repeat the process, or can I use the, so because I don't know where is your difficulty, so can I use this result?
It's okay. It's okay.
You're gonna use. It's okay.
Okay, I may just go that AT is just A0. I don't know what is A0 times exponent. Mu here is equal to 1, and sigma squared is equal to
16.
sigma yeah, yeah, this is like 1, and this is like mu, and this is like sigma. Yeah, so that's the equation we have solved already. How to solve it? We take logarithms, we apply it as lemma, and so on. So it will be 1 minus 4 squared over 2t plus 4wt. Okay. Now let's go. So we have completely solved an equation that is simpler, but that's not what we want. Yeah, because we are supposed to solve the original equation, and the original equation contains t cubed. So let's go back to original equation. So let's normalize a0 to 1. It doesn't matter, because when we have a representation like yt, so second step, we have representation yt is at times bt. Yeah, and obviously you can put constant like this representation obviously is not unique. You may say write something like 7. So obviously any number you can say 7 is like or maybe it's better to have 12 is like 4 times 3, or 12 is 6 times 2. So obviously representation in terms of a product is not unique. You may arbitrarily choose a constant in A, and the constant in B will change will change correspondingly. So let's put a0 equal to 1. It doesn't matter. Okay. Now we have yt equal to atbt, and because we have studied only its lemma, so what can I apply? I can apply it as lemma. I don't know something more difficult than its lemma. So just we have what to do, plug in, and its lemma. We have two weapons. So let's apply our sword like its lemma. So let's apply dyt. So we calculate dyt. What is dyt? So we have yt, that is a function of at and bt. So our function is a function of two processes. And first, let's write its lemma. So we have h with respect to a times dat plus h with respect to b times dbt plus, in general, I will write general form, but I will simplify it for my process. So it will be 1 over 2 h prime prime with respect to aa dat squared plus h prime prime with respect to bb dbt squared plus 2 h prime prime with respect to a with respect to b times dbt dat. So this is its lemma. In our particular case, I think almost everything is 0. Yeah. So so this is general form. This is general form. Maybe not so general. You may also have so you may have also more general, something like yt is a function of at, bt, and t. In this case, you will have one more term like h prime with respect to t times dt. So, but in my case, so let's write general form, and in my particular case, what will happen? Okay, this is just its lemma. Yeah, its lemma. Okay, let's move on. Let me have in my particular case, dyt is just bt dat plus at dbt plus 0 plus 1 over 2. What do I have here? I have there 0 plus 0 plus, what is the second derivative? It's 2, sorry, 1. So yes, it's 1, yeah? Times 2,
Like multiplied by
times
2.
1, dBt dAt. Okay. So let's go on. We have dyt is bt dAt plus at dBt plus dBt dAt. Okay. So now let's plug in everything we know. What is dyt? Dyt is just yt dt plus t cube plus 4yt dyt, that is dyt, according to our original equation. What happens there? Okay, it's bt times, what is dat? Dat is at dt plus 4at dyt plus at times dbt. For the moment, I don't know dbt, plus, for the moment, I don't know dbt. Dat we have it. At dt plus 4at dwt. Okay, so let's see what will cancel out. Yeah. So let's see what will cancel out. I see that this term will, I think, cancel out. Yeah.
Yes.
What else? 4yt and this term will cancel out. Yeah.
Yes.
Yes.
Okay, so let's simplify a little bit. We have 0, oh sorry, not 0, t cube times dwt is at dbt, I don't know dbt yet, plus dbt times a dt plus 4, what is it? Or what is it? AD
DWTs. 480.
480. Okay, 480 dWt. Let's think a little bit. When you multiply, so dBt, I suppose that BT is a iterative process. So when I multiply dt times anything, so I don't want, I don't know what is dBt, but according to its symbolic rules, when I multiply dt by anything, it will be
0.
0.
0. Okay. So and dBt is something like dt plus something like dwt. Okay, so I see that this term and that term will, the product, symbolic calculations will be 0. Okay, that's much simpler. Okay, t cubed dwt equals to at dbt plus dbt times 4at dwt. Okay, I don't know dbt yet. So let's go on. dbt, let it be, I don't know, dbt will be some let's denote it by Q, T, A and B are already used. Yeah. dBt is Qt times dt plus pt times dwt. Okay. What will I have? T cube dwt should be equal to at times d times qt dt plus pt dwt plus, and here dwt times dt will be equal to what?
dt. Wait, dwt by what?
So my
By
main
dt 0.
Yeah, by dt 0. So I will have here only
dt.
yeah, I will have only I will have only 4at times pt times dt. Yeah.
Yes.
Am I
Yes.
right?
Yes.
Let me check, because with small screen it's much more difficult for you and for me, because with a whiteboard, I have a whiteboard, I can leave previous results. Okay, let me check. D4A, it's, so I will use another color. It's 4A. Okay. And yeah, I think that's correct. dw times dt is 0, dw times dw is just dt. So okay.
What is
yeah.
What is Qt and PT? Functions of time.
We don't know yet.
But what can they be? Functions of time and Ito's process, or what? Qt and PT.
Maybe, I don't know. I'm trying to solve.
Why you use index T?
But normally any ITES process, we are studying good processes, we are studying ITES processes, and every ITES process is a sum of two integrals of Riemann integral and ITES integral. So it's just a class of processes where we can apply ITES lemma.
So, okay, so Qt and PT are unknown. That can be functions, processes, anything, right?
Yeah. We are trying to solve. We are trying to choose Qt and PT in such a way to solve the equation. I don't know them yet. Maybe they are ugly function and I will not able to solve, but.
And can we say that Qt and PT are functions of T and Wiener process? Like, do you noted it? Okay.
Yeah.
Thank
Yeah.
you.
Let's do like this. Okay. So what we have here? We have so we see that. So first I remark that dt should. So let's. We have end of page. So I will copy and recopy on the next page. There's a case that this problem is lengthy. It's supposed to be long. So there are problems that are more or less short, more or less long. So this exercise, it's okay that we are solving it. It's okay. It was supposed to be long. So just a copy to make PTDWT plus 4AT PTDT. Okay, let's go on. Okay, I will copy T cube dWT A times Qt plus 4PT dt plus PT dWT. Okay.
You forgot 4?
Yeah, sure.
Okay, what is before dt? In the left-hand side, I have 0. In the right-hand side, I have qt plus 4pt, and at is always greater than 0 because it's exponent of something. I don't, so I should have the same term before dt, and I should have the same term before wt. In the left-hand side, I have t cube. In the right-hand side, I have at times pt. Okay?
Yes.
Okay. Now let's go to, so at is known. At is exponent of, I don't remember, but it's known.
Minus 7t plus
Sorry,
4wt.
just a moment, just a moment. At is known. It's exponent of minus
7t
7t plus
4wt.
wt. Okay, so I can immediately find the pt. Pt is just t cube divided by at. So it's t cube multiplied by exponent of 7t minus 4wt. Pt is known. Now let's go for qt. Qt is minus 4 pt, and it is minus 4 t cube exponent of 7t minus 4 wt. Okay.
Excuse me, I don't understand where we got that AT is greater than 0 here. And why do we? I thought that the blue thing was before this exponent came. Okay.
But that's the answer. We have obtained AT. Yes, I have written this before because I remembered that it has a form exponent of something. I don't care. So this result was obtained before at step 1. So this result, it was obtained at step 1. And so I can, so it's non-zero. So to make 0 dt part, so I need a q plus 4pt equal to 0. Okay, so basically we know that dbt is pt dt. Yeah, it was pt. I don't remember what is.
It was qt dt plus pt.
Qt before dt. Okay, it was qt before dt plus pt before dwt. So it is minus 4t cube exponent of 7t minus 4wt dt plus t cube exponent of 7t minus 4wt dwt. Okay, dbt. So bt is b0 plus integral from 0 to t 4u exponent du plus integral from 0 to t u cube exponent of 7u minus 4wu dwu. And finally, yt is at times bt. We need to get the value of b0, but if a0 is 1, the b0 is also 1. And we have solved everything. At, we know at. It is, I don't remember, but it was
1
something like
plus
exponent of
Minus
7
7t
minus
7.
7t plus 4wt
Yeah.
multiplied by 1 minus 1 integral du plus second integral dwu. So it's our solution. We are happy.
Excuse me, how did we obtain that a0 is equal to 1
We
in the first step?
defined it as 1.
Ah, okay. Mhm.
If you
but
define
we
it,
can as well cross them out from the integrals, I guess, and it will be just it also crosses
it
out
doesn't
without
matter.
assuming.
So you may put it like 4, and b0 will be 1 over 4. So it doesn't matter. It will cancel out.
Yes, Boris.
Mhm.
I've
Okay.
read recently that if we have two independent Wiener process, right? Then,
Yeah.
for instance, we have WT and W bar T. And if they're independent, then dWt multiplied by dW bar T is 0.
Yes.
And hence, is it correct to say that this property can be used for any other processes that are also independent? We have two ethos processes, right? AT and here it's AT and BT, for instance.
But they are dependent.
But if they're not, then we can use this property, right?
If they are not, if they are independent and they are ethos processes, and yes.
Okay. And can you say, maybe explain, how can we understand that these two processes are dependent before solving for BT? We have the solution for AT, right? It definitely does not depend on BT. Then we have the form.
They obviously it depends on T and WT, and AT
Yeah, okay.
depends on T and WT. So the most important is WT,
Mhm.
and BT depends on WT. They depend on the same WT. In your example, you stated that there are two independent Wiener processes in your model, and in my case, I have only one WT,
Mhm.
and both AT and BT depends on the same WT.
That makes sense. Yeah, thank you.
Okay, so in this example, maybe something that scares you, that we left two integrals, but that's okay. These integrals, they do not include original function. So why we can say it's a solution? Yeah, why? Because in original, I may write. So maybe what scares you in this exercise? So if I consider original process, it was dyt was equal to yt dt plus t cube plus 4yt dwt, and maybe we can write yt like 1 plus integral from 0 to t yu du plus integral from 0 to t u cube plus 4 yu dwu. That's okay, that's correct. But the problem that we cannot say why my answer is some kind of solution and this is not a solution. Two integrals there, two integrals there. What's the difference? The difference that right-hand side contains yu, which is unknown. Yeah, so it is a stochastic integral equation. And in this case, yes, I have two integrals. Yes, these two integrals we may check whether we can solve them, but no, I think because of U cube, I think there are no explicit solutions. We cannot get rid of integrals, but this is solution because right-hand side contains no yt. There are no yt, no at, no bt. So everything is removed. Unknowns are removed from right-hand side. So that's why we can call it a solution. But it's a normal case that the final answer can contain integrals that can be calculated explicitly. It's okay. So what is bad, that your answer contains original function. That is not acceptable. That is not an answer. I'm solving differential equation and I obtain an answer that depends on the function itself, which is unknown. That's an equation. That's not a solution. But integrals are okay. So I have this warning in the home assignment, but once again, if you have integrals in your answer, then that's okay, provided that your integrals do not contain unknown functions, okay?
Mhm.
So the answer may scare you, you may be scared, but that's okay to have integrals in a final answer, because only in very simple case, stochastic integrals can be calculated. So we know basically integral from something like 7 dwu, that will give you 7 wt. You know, integral from 0 to t wu dwu, that is wt squared minus t squared, and basically that's all. So it's a very rare case when you can calculate the stochastic integral as explicit function of wt and t. Normally it's left as an integral. It's okay, but this warning is present in the home assignment, so it's not a surprise. So
Excuse me, can I ask you a question?
yes. We have a relaxed lecture, like no new topics are covered. So yes.
So when we leave from the integrals, why do we put it out like a constant? Why don't we take integrals with it?
Sorry, I don't understand. I may number steps. I don't understand. Oh, so it's 1, 2, 3, 4, 5. Could you reformulate your question? I'd like to respond, but
Yes. So can you please explain what you did when you took exponents out of these brackets?
no. I didn't take exponent. No, it's just AT. So inside these integrals, maybe it's better to write explicitly. No. I have
see,
the same.
B0,
I have the same.
0 is 1, yes, and that's why you just shortly inserted it. Okay.
So it just, I'm just a little bit lazy, so I haven't copied completely, but I need all. It's not. It derives from AT. It is not. So B0 is 1, and so it's not like, no, you cannot move 4u cube outside integral. So no, it's not possible. You have you need to you can take out of an integral only constants, and obviously 7t plus 4wt is not a constant.
Yes, but you took exponent out of brackets, no, in BT.
No. Where I took out exponents.
So they are still there.
Yes, they are still there.
Yes. Complete. This is, so let me write the answer once again without being lazy. So it's what? Oops. it's yt equals to exponent minus 7t plus 4wt times big bracket 1 minus integral from 0 to t. What is left there? 4u cube exponent of 7u minus 4wu du minus integral from 0 to t.
There will be plus, I believe.
Yes, plus
U in power 3.
u cube exponent of 7u minus 4u dwu. No, and big bracket is closing. So it's not like I have taken out of an exponent something. That's a bad action to take a non-constant function out of an integral. It's not. So only bad guys do like this. I'm a good guy.
Yes, and can you please go up a little bit?
Yeah.
The previous page. Yes, here. Can you please go up? Yes, what is it in dyt? You multiply dat in the end to yt dt?
Just let me add some more lines. So this will be line 1, line 2, line 3, line 4, line 5, line 6, line 7.
It's
line
enough, it's
8.
enough.
Okay.
Yes, so when you go from 3 to 4, what is it? A multiplication of dat to yt dt?
So I replace, this is original equation. We have original equation. This is original equation. And multiplication there.
Oh, I mean, in the end of the third line, dat, what is it? You multiply it?
Multiplication,
And
just a point.
Okay, that's what I wanted to say. Thank you.
May I ask a question?
Yes.
So,
we have a relax. Just relax and ask the question.
Do you have any tips and tricks, like what substitution for yt to use for stochastic differential equations? For example, sometimes you suggest to say that yt is logarithm. Sometimes it's just like function of t multiplied by another function of wt. Sometimes it's just at by bt. So like, do you have any tips on that?
These are my clues.
It's just clues. You do like maybe on some functional form of stochastic differential equation, you understand that we can use this substitution or this one. Do you have something like this or just on random?
So we have just examples. So it's art.
Okay.
So solving differential equations. So when you calculate derivative, it's a job. It's not an art. When you solve differential equations, then yes, there are some techniques. You may represent yt as a product of two processes. That's a good technique. If you have that, if you see that it's somehow related to exponent, then it's reasonable to take logarithm. But basically, that's not. It's not like you have no direct procedure. Oh, you see, even like with differential equation, without stochastic calculus. So when you see a differential equation, either you say, oh, I know this. This is linear differential equation. I know how to solve it. Oh, I have experience. This is linear differential equation. I can write characteristic equation and so on. Oh, this is, I don't know, Bernoulli differential equation. Oh, I know that I need to divide by xt power b and replace arrive to linear differential equations. It's like with ordinary differential equations. Either you have preclassified types, either it's not. So basically, we need to. So the goal of my course is to provide you with knowledge about sigma algebras, conditional expected value, stochastic differential equations a little bit, and it is lemma and Wiener process, its property. So basically, that's my goal in six meetings, like classes or lectures. That's not important how you call them. And basically, these techniques are used in financial applications. I'm not a guru of financial applications, not at all. So my short introduction is just to basic Black-Scholes model, and you will have financial courses after it that will use this machinery of Brownian motion, Ito's lemma, calculate expected value and obtain current price, Girsanov theorem. So basically, I provide mathematical tools. And my goal is not to go very deep into stochastic differential equations. So just you have techniques. So I'm equipping you with some weapons to solve, so to go into a fight. But okay. Any more questions?
So could we here apply the approach when we want to find dt? We equals it to qt dt plus pt dwt. So could we apply the approach like we did dbt is equal to function h of t multiplied by g of wt? Is the same identical one approach?
No, because we see that in our case, BT is a very complex process. Yeah, we see that this process, so you can try to apply it, but you will fail because this process is very complex. Obviously, it's not a function of just T and WT. So we see from this answer, we see that BT is not just some function of T and WT, because it depends. So from this integral, we see that BT depends on the whole trajectory of Wiener process from 0 up to T, not only on the last value.
So how can we understand that we cannot use this substitution?
Try it and you will obtain a contradiction.
Yeah, thank you.
So basically, solving stochastic differential equations, it's a knot. You have a hint that just try to represent. So I just follow the hint and I use it as lemma. When you will fail, let's check when we will fail. Assume. So let's use. That's a good idea. Let's go into the. So let's use a wrong substitution. Yeah. Let's see. That's a good idea. Let's see what happens. Let's see what happens if I
tried like this, and there was only T, but no WT.
Yeah, I think
and it was, so I understood that it was wrong.
Yeah, let's see what happens if I use wrong guess. Yeah, because some guesses are wrong. That's okay to have wrong guesses. So if I guess that BT is what? Some function h of t times g of wt, yeah, like this.
Yes.
Yeah, and so in this case, what will be dyt? We should have from equation. We have that it is I forgot already. Yt dt plus t cube plus 4yt dyt, and from Ito's lemma, from equation, from Ito's lemma, we have that it is equal to, I don't remember. Here it is, yeah?
Yes.
I think it's here, yeah? Or maybe, yeah, it's here, yeah, BT, DAT, yeah, let's find. From Ito's lemma, it's AT dBT plus BT times DAT plus dBT times DAT, yeah? And I think I will just fail to equate these two parts. Let's check. So it will be So it will be from Ito's lemma. I don't remember AT. Let me write it. So AT was so this is left-hand side, and this is right-hand side. In the left-hand side, I have AT, BT, DT plus T cube plus 4AT, BT, dWt. In the right-hand side, I have AT. What is dBT? What is dBT? It's it's bad guy. So let's write dBT.
Maybe we would solve something more related to exam.
And why this is not related to exam? It's use of Ito's lemma.
Yeah, I know, but it is about wrong substitution, and anyways,
Yeah.
we will get wrong result.
Yes.
Okay.
Yes, that's exactly because you have a bad feeling, because normally when I'm solving, yes, I can do mistakes, but normally I know I have more experience than you with Ito's lemma and so on. And basically I'm solving, so I can do mistakes, but normally I solve using the right approach, or at least one of the approaches that will lead me to a solution. Maybe not the best one, maybe there is a greater substitution and so on, but basically I'm following the road that will lead to success. And when you solve normally, you are trying bad ideas sometimes. That's okay. And it's important to know where I can. I think that's a good idea to know what will signal me that my approach is wrong. Where I can tell that my idea was wrong, I need to check another idea. So this is just a guess. And so basically, when I present a problem with hints for stochastic differential equation on exam, I try to solve it before, obviously, and I give you guiding hints. But if you will lose the path, how can you go back on track? So how can you understand that you have done something wrong? So I think that's a good idea to understand. And basically, I think when I will equate right-hand side and left-hand side, I think they will just not match. But if it seems boring to you, okay, I can solve anything you wish. That's okay. But I think so. If I take dBt, it will be h prime gwt dwt plus what? Plus h g prime dw plus h 1 over 2 h g prime prime dt. Okay. And if I plug in, what will I have? I will have
Excuse me, why the first term is dwt?
sorry, yeah, it's dt. Yeah, it's dt. Okay. And if I plug in here, yeah, if I plug in here, I will have I will have what? I will have ATBT HG dt plus t cube plus 4a hg dwt. That should be equal to a dbt a h prime g dt plus a h g prime dw plus 1 over 2 a h g prime prime dt. Ooh. plus plus bt hg times dA. dA is a dt plus 4a dwt plus dbt dat. Oh, this will be easy because only dwt term, I need to check only dwt term. So dwt will go from here hg prime dwt times 4a dwt, and that's all, I think. Yeah. Yeah, and so we have a big equation if we choose the wrong path, and let's see where we can see a contradiction. So something will simplify, I think. AHG will simplify. Where it is. No. So this part will simplify. Yeah, 4AHG. So this will simplify. What else will be simplified? What else will be simplified?
In the same brackets, I guess, with the first,
Yeah.
very first term.
Yeah, this will be simplified. Okay, so I will get equation t cube times dwt should be equal to, ahg prime dwt plus, and everything else will be with dt. Everything else will be with dt plus dt times what? Ah prime g plus 1 over 2 ah g prime prime plus h g prime a dt. Yeah, I think like this. So what do I have? I have that t cube is equal to a times h times g prime. Yeah. What do I have? I have that ah prime g plus 1 over 2 ah g
Haven't
prime
you
prime.
lost 1, 4?
What have I lost?
Yeah, there in the bracket,
4,
the
yeah?
last term should be multiplied by 4, right?
Yeah.
Yeah.
Plus 4h g prime a. Yeah, that should be 0. Oof. How can we manage to solve it? So we can cancel a. Yeah. So it's t cube like ah g prime h prime g plus 1 over 2 h g prime prime plus 4 h g prime should be 0. Rum. Okay. Okay. So the only way to cancel random terms is to have, so in A, we have exponent of, as far as I remember, minus 7t plus 4wt, yeah?
Yeah.
So the only way to cancel the randomness in the right-hand side is to have g prime is equal to exponent of minus 4wt. This is the only way to cancel randomness, because in our case, the only randomness in BT is g of wt. Okay. So I have g of wt. The only way is to have it exponent minus 4wt divided by minus 4. Yeah.
Yes.
So that's the only way to cancel randomness. So we have h. So we have h, and I think we will arrive finally at contradiction.
Yes, probably we will.
Yeah, probably we will. Exponent minus 4t. So let me copy the equations. H g prime.
Because I believe by multiplication on AT, there will be no WT left. So it will be just the YT will be just a function of T, and which is wrong given our first equation.
Yeah, you are right. We can see it easier. Yeah, we can. Yeah. I think you are right. Yeah, we can arrive at contradiction a little bit faster. Yeah, I will also arrive at contradiction, but your way is to see that this is but no. I think that's okay. So let's recall that g of wt is exponent of minus 4wt divided by minus 4. And then we can multiply everything by a. We will see that a h prime g plus 1/2 a h g prime prime plus, here we have 4t cube. Yeah. And this is all. And no, I think. No, I don't see your point. So I think we need a honest contradiction. No, I can see it very quick. How do you see a contradiction quickly?
I thought that BT
Well,
is
let me number. Let me number. 1, 2, 3, 4, 5, 6, 7, 8.
Well, we have thought that BT is HT multiplied by GWT.
Yeah.
And we know that
was our
YT is, yes, and we know that YT is AT multiplied by HT, by this thing. And yeah, and we know that HT depends only on T, and we see the form of GWT and AT just upper. And when we multiply GWT by AT, there will be no WT left for YT.
Yeah, I agree. Yeah, that's a quick contradiction. Yeah, you see immediately that YT is a H of T times something. Yeah, you're right. It's a fast contradiction. Yeah, that's great. Only a function of t, and that's a contradiction, because in this case, you will have no dwt in equation. Yeah, you're right. Yeah, that's a faster way to obtain a contradiction. So this guess was wrong, but it takes sometimes to understand that it was a wrong guess. That's why it's a home assignment. So in a exam, normally I add more hints about on the path to
Thank
stochastic
you for
differential
that.
equation solution. So because yeah, sometimes when you solve stochastic differential equations, you may have wrong guesses. That's okay.
Excuse me, I had a question about this page.
Yeah.
I didn't understand. Well, in the expression number 8, we obtained it by, as I understood, integrating G prime.
Yeah. We have. I've removed 7.5. It was that G prime should, because I have functions only of t cubed depends on t, h depends on t. So a and G prime should remove all randomness. A multiplied by G prime should be non-random. So G prime should be exponent of -4 Wt.
And the thing I didn't understand is why we can integrate like the usual function.
Because G is a usual function. G is a non-random function at a random point. So if you can, so my point is that G is a function. You can draw it. If you put here like something V, you can draw G of V is exponent -4V. And it goes like this. G prime is a usual derivative. No miracles, just the point is random. When I say G prime of Wt, then this is the usual derivative, and this is a random point.
Okay, thank you, I got it.
Excuse me, can you please repeat the contradiction part again? So it is only a function of t. Yeah, we say that yt is only a function of t, but in dyt we have dwt, and it is a contradiction. Yes.
Yes.
Why don't we assume that it's just the coefficient b before dyt is 0, for example?
Yes, we need to check this last opportunity to save. Yes, you need to check. Yeah, honestly speaking, you are right. You need to check an opportunity that t cube plus 4yt is 0, but I think that's wrong. So if you check this opportunity, so yes, you have the last opportunity to save this guess, to have yt equal to minus t cube over 4. But in this case, you are right. The coefficient before dwt will cancel out. But if you check the last chance to save, the wrong guess fails. Yes, you are right. Because maybe it has dwt multiplied by 0, and so it seems that yt is random, but yt is non-random. Yes, it may be. I may write such an equation, something like, yes, it will be fun, something like yt is just 3t squared, and obviously I may write that dyt is 6t dt plus t squared minus 1/3 yt dwt. Yeah. Obviously, that's a solution. Yeah. Yeah, that's a solution. But your last effort to save the wrong guess fails. So basically, you're right. We need to check whether maybe the term before dwt is 0.
Okay, thank you.
Okay. So I think that's all for today. Have a nice time. Prepare for your exams. So go outside and see the snow, the winter. Thank you. So we will have twice the amount of hours for consultation, and basically solve past exams. So my policy is to have everything passed, to have open. If I have any solutions, they are published. So I keep secret only future exams, not past exams. So everything past is available to you. I have no hidden solutions, so just try to solve what is published. You have, let's say, roughly 30 pages to solve, to understand solutions. If you, not all of them are with solutions, but I try to do my best in a limited amount of time. So see you next time. Be brave. Don't be shy to ask questions. Thank you.
Maybe if you
May I ask a
Yeah.
question about
Yeah,
the
you
exam?
may.
So if we use your hints on the exam, it's okay, right? We don't use.
Yeah, you have two strategies. Either you have brilliant idea and you completely ignore the hints about stochastic differential equation, you solve it. You will receive a 10 out of 10 for the problem. Maybe even more. If I like idea, I will give you bonus points. But if you follow them, that's a path that I have tested that leads to a solution. Maybe there are other paths, maybe even shorter than mine. It's okay. You will provide me a shorter solution. I will certainly put you 10 out of 10 and maybe even more if I'm amazed by if your solution is beautiful. So basically, and usually I write, you may use or not use hints to say that you are free to use hints. So if you have no clues, you may try to represent. So you may try, you may not. If you have any ideas, any other ideas. So.
I'm sorry, have you already created an exam for us?
I have 2 or 3 problems in mind, but not all of them.
Okay, I just wanted to ask about structure and so on, but maybe later.
About structure, but just you will have, I think, what is a little bit non-risky. I have, I think, about 6 problems. What else? What is the structure? You have open problems. So the topics we have covered is just from sigma algebras, martingales, conditional. So what we have covered is just sigma algebras, conditional expected value, or conditional variance, martingales, Dup's theorem. What we have covered more sigma algebras, but stopping time. So maybe it's better to say it before Dup's theorem, but never mind stopping time. Should move it there. What else have we covered? Conditional expected value. So now let's move to continue. So we have basically 2 big parts, yeah, discrete time and continuous time. In continuous time, what do we have? We have so Dup's theorem without checking technical assumptions. Yeah, we believe that but if there will be a task on Doob theorem, so it will be written that you can safely ignore testing all the assumptions. So what we have a winner process and its properties. Yeah. We have basically it is integral. It is integral, and its properties. The main property is it is lemma. It is lemma. We have once again Doob's theorem. Yeah, the same. Doob's theorem. What else? But basically, I think we, which is integral, it is lemma, Gersanov theorem, Black-Scholes model, pricing. I think that's all we have covered. Let me see a little bit.
Что-то мне кажется, что я ни одно из этих названий не знаю.
Which one?
Ни одно.
Which one?
Допустим, Doob's theorem.
Optional stopping time theorem.
А можно еще вопрос? У вас же в среду будут офисы на этой неделе?
In the problem 3, it's written using Doob's theorem. Why do you know? So and
I think it is someone not from our group.
But
actually.
anyway. So optional stopping time theorem. So it's about when you stop a martingale and you calculate expected value. Yeah. Any questions?
У вас в эту среду будут офисы, да?
I'm answering your questions. If you have questions, I will answer them. If you have no questions, I don't answer them. It's not like you arrive and I tell you something. No, that's not like this. If you have questions, don't be shy. If you are shy to ask your questions, it's not like a optional lecture, optional class.
Поняла.
If you have questions, don't be shy, ask them. If you are shy, I'm silent. That's not like you arrive and I have prepared 5 problems for you. So no questions from your side, then I do nothing. Okay, so that's all. If you have yeah.
I'm shy because my question is not shy, but maybe I should try to ask you. Despite the fact that we have online course, maybe you would give us an advantage that you would specify some topics. For example, you could say that then problem 6 would be about differential equations, and we will try to solve as many differential equations because you stated about 10 or maybe more topics, and they're too huge to cover all of them and try to solve all the tasks for 10 days. And maybe if you would give us
it's not a question. It's not a question. You asked me to do your work, so you have a lot of questions. Just try to solve them. If you have any difficulties, then that's okay. So show your work. If you arrive and say, I have solved the problem number 6 and I'm stuck there, and it's okay. But your point is there are many problems with solutions. Yeah. So you are asking me just to read solutions aloud. So what's the point? So if you are stuck when you are solving past exams, and it's okay. I'm solving problem number 5, but I can't understand how to go from point 3 to point 4. That's okay. That's a good question. But like this, provide me 10 more problems. That's not a question. So what was your effort? So if you are stuck, if there are a lot of examples in past exams, it's not 2 years, it's not 3 years. You have a lot of past exams. So just try to solve them by yourself. And if you have questions, and that's okay. But your It's not a question. It's not just what is a question. It's a proposition what to do for me, but it's not a question. You just,
Excuse me, I have a question.
Yeah.
I was absent on, I think, one seminar, and I just wondered, we didn't cover the Markov chains, right? Because you mentioned it in the beginning of the course that probably we're going to do it, and I just wanted to make sure if
no, we haven't covered Markov chains.
Okay, thank you.
But it's a good idea to cover them on the exam. Yeah, that's a good idea. Yeah.
I have one more question. Can you
Yeah.
please state what exactly Doob's theorem is? So we have apply it in our homework, but maybe it has some, it can be extended or something else.
No, just, so what is Doob's theorem? Just you say Doob's theorem. If you missed the lecture, you have just optional stopping time theorem. Optional. So let me Google for you. Stopping time theorem. So I have posted a link to optional stopping time theorem.
It's the same. Exactly.
Yes, it's
Okay.
written Doob's theorem, optional stopping time theorem. Okay, if some technical conditions, MT is a martingale, tau is a stopping time with respect to some filtration F T, then expected value of M tau is expected value of M0. If you'd like to go deep into these conditions, so you can follow the link I have posted.
Okay,
If
thank you.
it's just a general idea, if MT is a martingale, tau is a stopping time with respect to some filtrations. There are some more technical conditions. We have stated them, but we are not required to check them on exam. So then you basically, it says you cannot make money when you decide when to stop. If you invest into a martingale, if your strategy to stop is not looking into the future. So if your strategy is a honest stopping time, you are not using some miracles like I will stop before the price will go down by 20. That's a bad strategy. It's not a stopping time. But if you have a stopping time, I stop after increase by 10. So using honest stopping times, basically it's intuitively obvious thing that when you invest in something that changes randomly, that can go up or down with equal probabilities, so intuition is very clear. You cannot make money if you don't look into the future and you invest into something that is a martingale. So basically that's the meaning of the theorem. There are some technical convergence conditions. We have even discussed them a little bit, but you are not required to check them on exam, and I will write this explicitly.
Okay, thank you. I got it.
Boris Borisovich, may I ask a question, please, about the Dobbs theorem?
Yeah.
Isn't the same as necessary condition for the martingale? Because it looks like very similar to it.
Yeah, it looks similar to necessary condition for a martingale. So what's the question? Does it look?
Maybe.
So yes,
I mean that maybe stopping time is just a particular t.
Stopping time is a random variable with some properties. It's not particular t.
So it's just so this theorem is just looking like a necessary condition for
Yeah, from yes, yes, but the point is the necessary condition you mentioned is like this. So if MT is a martingale, then expected value of MT is expected value of M0. And you may say that this is a very simple case of optional stopping time theorem. Here, T in your case is non-random. But in Dup's theorem, tau is random. Yeah, you may say that it's a generalization of necessary condition. Yeah, you may say that Dup's theorem generalize. Yeah, I think you are right. In that sense, Dupin optional stopping time theorem generalizes this necessary condition, because necessary condition is about non-random T. So you just stop at 5. When you decided to stop at 5, then you have a martingale. Your expected value is the starting expected value. And Dup's theorem says, even if you stop at random moment of time, provided that you don't look into the future, then your expected value at the final moment is initial expected value. Yes, in some sense, you are right. Yeah, it seems, yeah, it's about the same thing. But in optional stopping time, tau is random, and in necessary condition, T is non-random. Okay?
Understood. Thank you very much for the explanations.
I have one small question. May I ask it
Yeah.
really quick?
Yeah.
About Ito's lemma.
Yeah.
On this on today's class, we had that the part which was multiplied by dt. You said according to Ito's lemma should be equal to 0.
Which part?
It was before we tried the wrong substitution.
Yeah. Here it is on the screen. What's the question?
So we multiplied dt by a bracket and a long bracket, and we
Could you please
said
refer
that
to numbers?
I don't see it here.
I think the question relates why dt dwt and dt dt equals to 0.
Not really. Okay. This thing, 8, the expression
8,
number 8,
yeah.
I think. You said that according to Ito's lemma, it should be
Yeah.
equal to 0, or maybe
Yeah.
I didn't hear.
Yeah, you are right.
Maybe I don't understand something, but I thought that Ito's lemma was about.
Yeah, but Ito's lemma provides us some symbolic rules. dt times dt is 0. dt times dwt is 0. dwt
Okay,
times
now I see.
dwt is, sorry, not 0 by dt. So just.
Yeah, now I see where it comes from. Thank you.
Okay, have a nice
So
day.
May I quickly ask a question about this? You said about 2-hour consultation, right?
Yeah.
And do you know when it will be held?
I think 1 or 2 days before exam.
So
I think
it
the
may be
exam
that
is
it will be
29,
between
28 or 27, so something like this.
Yeah, that's why I wanted to ask that this consultation will be around like
Okay, yeah.
26th, 28th of December.
But it's normal because before you will prepare to previous
Yeah,
exams.
to other, yeah. Mhm.
I'm ready.
Thank
So
you.
if you have questions, just don't be shy, post in the chat. And when I have time, I will answer them. So even you have questions before consultation, it's okay. But normally.
Thank you, great.
Okay, bye-bye.
Thank you.
Thank you, bye.